Today we're going to be going over power to power and dividing with positive exponents. So content objective is students will be able to simplify expressions with power to power and division with positive exponents. Language objective is students will be able to discuss what dividing with exponents and raising a power to power means. And why am I learning this? Well, it's important for real-world problems like predicting population growth. So first we're going to go over some background knowledge. We're going to look at what extending products mean and whether or not our products will be positive or negative. So here, what am I going to do? Well, what is being raised to the second power? It is a -5. So that's going to be -5 times -5, which would, of course, equal a positive number. Number 2, here, be very careful. Okay, a lot of students are going to want to multiply a negative times a negative and say, oh, now it's a +6. But that's not what we're supposed to do. According to order of operation, it's please excuse my dear Aunt Sally. Parentheses come first. I have to simplify what's in the parentheses. Then comes exponents. So I'm supposed to cube the -6 first. So essentially what this looks like is -6 repeated 3 times, but this negative on the outside would still be there. So how would I read this? I would read this as the opposite of -6 cubed. So here, I like to pair up my negatives so that I know what's going to become positive. This is going to become a positive number because a negative times a negative is positive. This will become a positive because a negative times a negative is positive. So here, my answer is a positive. Okay. What about number 3? Well, this we would read it as the opposite of 7 squared. So if we took 7 squared, okay, we're going to take the opposite of it. So we're going to mark that on the outside. So here, my answer is going to be a negative answer. Last one here. So again, we would read this as the opposite of -2 cubed. So first, we're going to go ahead and cube this -2, but we're going to keep the negative on the outside. So let me just show you real quick. I'm going to go ahead and write -2 3 times, but I'm going to go ahead and keep this negative on the outside. So here, is my answer going to be negative or positive? Let's see. This is going to be a positive. This will become a positive. So my answer is going to be a positive number. Okay, so now, quick review of how we would multiply with the same base. I would extend this out using extended products. 4 cubed means 4 times 4 times 4. 4 squared means 4 times 4. So altogether, there's 5 of them. So I'd write that as 4 to the 5th. I am going to be going through these slides pretty quickly, so if you would like me to slow down, you might want to check the previous video. Okay, so here, what about this? What I like to do is first regroup them. So I'm going to group all the 3's together. So I'm going to put 3 squared times 3 to the 3rd. Basically, what allows me to do this is the commutative property of multiplication. It allows me to rearrange things, still retaining the same value. So now I'm going to write 4 squared times 4 to the 5th. At this point, what you're going to do is you're going to go ahead and use extended products and then to see how much you have all together. So this would be 3 to the 5th times 4 to the 7th. Okay, so now let's move on to what we're going to be learning today that's brand new. It's going to be power to power. For example, here we already have 5 raised to the 3rd power, or 5 cubed. But guess what? It's being raised to another power. It's being squared, or aka raised to the 2nd power. So what do I do here? Well, there's 2 ways to think of it. One way is you can go ahead and expand this out to 5 cubed means 5 times 5 times 5. And since it's squared, I'm going to go ahead and repeat this 2 times, like so. So now you can say I have a total of 6 5s, so I'm going to rewrite that as 5 to the 6th power. Now, to be completely honest, I wouldn't want to extend it this way to keep things a little bit more neat. I prefer to say, okay, what's being squared? It is a 5 cubed, so I'm going to go ahead and write 5 cubed 2 times, like so. Then once I have it at this stage, I will go ahead and use extended products and say 5 cubed means 5 times 5 times 5. 5 cubed means 5 times 5 times 5. So it means the same thing, but for me, this keeps things a little bit more neater. And my answer would still be the same, which is 5 to the 6th power. So let's look at some more examples. Okay, it says, using extended products, write the following expression in simplest exponential form with positive exponents. So they do want us to extend it first, and then they want us to simplify it in exponential form. So we're not going to evaluate it all. So here, I'm going to say what's being raised to the 4th power. It's a 3 squared. So I'm just going to go ahead and write 3 squared 4 times. At this point, I'm going to go ahead and extend each 3 squared. Okay, so this is the 3 squared, this is 3 squared, 3 squared, 3 squared. So altogether, I have a total of 2, 4, 6, 8. So I'm going to rewrite that as 3 to the 8th power. Okay, so now let's go ahead and try number 6. Same idea. What's being squared? It is a 7 squared. So I'm going to go ahead and write 7 squared 2 times. And then after this point, I'm going to go ahead and extend 7 squared into an extended product and say 7 squared is 7 times 7. 7 squared is 7 times 7. So altogether, there is 1, 2, 3, 4. So I would write that as 7 to the 4th power. Okay, so now what about this problem? So this one's very similar, except I'm noticing something. 3 is being raised, what's being raised to the 3rd power? A negative 8 cubed. And notice I said negative 8 cubed because there's parentheses surrounding it. If there wasn't, I would say the opposite of 8 cubed. So keep that in mind. So here I'm going to go ahead and repeat negative 8 cubed 3 times. And then I'm going to go ahead and extend each and every negative 8 cubed, which looks like this. So just so that you can see a little bit clearer, here's my first set of negative 8 cubed. Here's my second set of negative 8 cubed. And here is my third set of negative 8 cubed. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write that as negative 8. So notice I did keep the parentheses because if the parentheses wasn't there, it would be read differently. So this is negative 8 to the 9th power. Now if I forgot the parentheses, it would be the opposite of 8 to the 9th power. So please notice that there's a difference. So you got to be careful. Okay. So now, what if I do power to power, but the bases are different? What do I do then? Well, it's the same idea. What's being squared? Everything in the parentheses is being squared. So I'm going to go ahead and repeat 2 cubed times 3 to the 4th 2 times. So it's going to look like this. So I went ahead and took this entire, you can kind of refer to it as a base because this is what's being repeated. I went ahead and took it and repeated it 2 times. So here's once, here's twice. Now, just like before, in order to figure out how many 2's I have altogether, how many 3's I have altogether, I'm going to go ahead and use a commutative property and rewrite so the 2's are together and the 3's are together. And then after this, go ahead and extend each one out. So here, my first group of 2 cubed is here. Second set of 2 cubed is here. Here, there was 3 to the 4, so my first set was here, and my second set was here. So at the end, I'm going to say there's a total of 6 2's, so that's 2 to the 6th, times, how many 3's are there? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to write 3 to the 8th power. Okay, so one thing I do want to mention is in my open math, because your homework assignment might be on my open math, how do you use this symbol in my open math? Simply type in this asterisk symbol, and that would be the equivalent of multiplication. Okay, moving on. So I want you to go ahead and pause the video and try number 8 on your own. Okay, let's see how well we did. So what is being raised to the 4th power? This whole expression, 3 squared times 4, is being raised to the 4th power. So I'm going to go ahead and take this and repeat it 4 times. 1, 2, 3, 4. Now at this point, I'm just going to go ahead and regroup using commutative property. Not regroup, sorry, rearrange. So now all the 3's are going to be together. So there was 4 of them, 3 squareds. And I'm going to collect all the 4's together, and since there was 4 of them, it looks like that. Here you're going to extend all the 3's in groups of 2. So it was my first group, second, third, fourth, because there was a set of 4 of them. So I would simplify this as 3 to the 1, 2, 3, 4, 5, 6, 7, 8 times 4 to the 1, 2, 3, 4 to the 4th power. And there you have it. Okay. So what you're going to notice today is you're going to definitely be using extended products, okay? Because you're showing yourself how I'm getting to this answer. You're extending out what does 3 squared really mean? What does 3 squared times 4 raised to the 4th power really mean? And that's how you're going to be able to get your answer. Okay, go ahead and try again and pause for number 9 and see how well you do. Okay, so I'm going to go ahead and ask myself what's being cubed. Well, it's 2 squared times 8 cubed. So I'm going to go ahead and take this expression and repeat it a total of 3 times. Here we go. I'm now going to regroup all the 2's together and all the 8's together. What allows me to do that is the commutative property. Now I'm going to extend every 2 squared out and every 8 cubed out, which is going to look like this. And again, if it helps you, I would group them so that I can keep track of how many times I repeated it. Like so. Here it was a group of 3, first group, second group, third group. So now I'm just going to write 2 to the 1, 2, 3, 4, 5, 6, 6 power, times 8 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's your answer. Hopefully you got it right. Okay, so now I'm going to go ahead and go over number 10. This is very similar. We're going to go ahead and ask ourselves what's being squared. This whole expression is being squared, so I'm going to go ahead and copy this expression exactly 2 times. Now I'm going to rearrange everything so that I can group all the 7's together and the 8's together. Sorry, not 7's, negative 7's. And at this point, I'm just going to extend this out. Negative 7 squared means negative 7 times negative 7. Here's my first group. Here's my second group. Same thing with 8 cubed. Here's my first group. Here's my second group. So here, please make sure, since your base is negative, you include that parentheses, because if you leave it out, it means something totally different. There's 4 of them, so I'm going to write to the 4th power times 8 to the 6, because there's 6 of them all together. So a common mistake might be some students will write it like this. This means something different. This means negative 7 to the 4th power. This means the opposite of 7 to the 4th power. So this will be wrong. So make sure if your base is negative, you include parentheses. Okay, so now we're going to go ahead and enter something slightly different. It says, using extended products, write the following expression in simplest exponential form with positive exponents and evaluate. So not only are we asked to extend it out, we're asked to simplify and also evaluate. So here, let's go back to the basics. What does 5 to the 6th power mean? Well, it means I'm going to repeat 5 6 times. 1, 2, 3, 4, 5, 6. Now, what does 5 to the 4th power represent? Well, it means 5 is repeated 4 times. So hopefully you start realizing, hey, I'm going to be able to cross-cancel or reduce some of the 5's. Here, 5 divided by 5 is 1, okay? Or you can think of it as 5 divided by 5 is 1, 5 divided by 5 is 1, or just understand 5 divided by 5 is just 1. So this is, you're going to go ahead and copy this trend, okay? Divide by 5 is 1, divide by 5 is 1. You keep going until you can't go any further, and you're going to be left with an answer. So here, since we're asked to write it in simplest exponential form, I would say that this leaves me with 5 squared over 1, which is the same thing as just 5 squared. And the last part is, since they're asking me to evaluate, I would say 5 times 5 is 25. So that's all that they're asking us to do. Okay. So now, let's go ahead and practice a couple more. Number 11, 7 to the 9th power. What does that mean? I'm going to write 7 9 times over 7 6 times. So here's 9 7's, and underneath I'm going to write 6. For myself, if I was doing this on my page that I'm showing my work, I would deliberately line up my 7 so it's easier to cross-cancel, but it's just total preference. For you, it really doesn't matter. So here, the 7's, 7 divided by 7 become 1. 7 divided by 7 becomes 1. Keep going until you can't go any further. And then at this point, I see that I have 3 left, so I'm going to write that as 7 cubed. But since they're asking me to evaluate, I'm going to multiply 7 times 7 is 49. 49 times 7 is 343. So again, this is my exponential form, simplest exponential form, and this is my answer evaluated. Okay, now let's try number 12. Here, what does 2 squared mean? It means 2 times 2. 2 squared also means 2 times 2. Now let's see what happens here. 2 divided by 2 becomes 1. 2 divided by 2 becomes 1. So really, all I'm left with is just 1's in the numerator and 1's in the denominator. So what's 1 divided by 1? The answer is 1. Okay? So here, I would just go ahead and say it's 1. You could go into saying simplified how many 2's are there. There's 0, but we're going to go more into detail with that tomorrow. Okay, so go ahead and pause the video and try number 13 on your own. Okay, so here, let's see how well we did. I'm going to go ahead and write 10 4 times in the numerator and 10 5 times in the denominator. So I'm going to go ahead and cross cancel. 10 divided by 10 is 1, 10 divided by 10 is 1, and keep going until you have nothing left. So here, be very careful. What's left in my numerator? It's just 1 times 1 times 1 times 1. So my numerator is a 1. Well, what's left in my denominator? It is a 10. So the key thing about number 13 is understand not everything will be in the numerator. There might be more of the bases in the denominator, and we must identify that by writing it as such. So that would be my answer, just 1/10. Now let's look at number 14 and 15. Again, go ahead and pause the video and try it on your own. Okay, let's see how well you did. So we're going to go ahead and extend the products, and then we're going to put in simplest form, exponential form, and evaluate. I'm going to put -2 2 times in the numerator and 4 times in the denominator. Here, the -2's divided by -2 is going to cancel out to 1. Keep going until you can't go any further. What's my numerator? Well, it's 1 times 1, which is just 1. In my denominator, I'm left with -2 repeated 2 times, so that's going to be squared. So that would be my exponential form, but I'm going to be asked to evaluate it, so I'm going to say, okay, this is going to leave me with 1 over a negative times a negative is a positive, so it's going to be 2 times 2, which is a 4. Okay. What about number 15? Hopefully you extended them out and saw that they cancel out each other completely, leaving you with just 1 over 1, which leaves you with 1. Okay, so now this is the same idea, but what if your bases are fractions? It's the same idea. I'm going to go ahead and repeat -2/3 4 times. I'm going to repeat -2/3 2 times. I'm going to cross cancel. -2/3 divided by -2/3 is still just 1. -2/3 divided by -2/3 is just 1. And here, I'm now left with -2/3 squared. So please remember, because it's a fraction, you're going to have to use parentheses to represent that. And also, because it's negative, definitely it would require parentheses to indicate that the base is negative. But now since it doesn't say to evaluate, I'm actually done. Moving on to number 17. Here, I'm going to go ahead and repeat it 4 times for the numerator. And here, since there is no exponent, I'm just going to copy this and write it once. So understand, when there is no exponent, by default, there's one of them. Okay? So here, I'm going to cross cancel, and I'm just left with -4/7. There's 3 of them, so I'm going to raise it to the 3rd power. Or you can say -4/7 cubed. Either way is correct. Okay. So now, using extended products, go ahead and try number 18 on your own. Okay, let's see how well you did. I'm going to go ahead and write -7 to the 4th power 4 times. And then in the denominator, I'm going to write -7 7 times. I'm going to cross cancel. -7 divided by -7 is 1. I keep going until there's nothing left. I can cross cancel. Here, what's my numerator? I'm left with 1 times 1 times 1 times 1, which is just 1. Here, I'm left with a base of -7 repeated 3 times. So again, since the base is negative, you need to make sure you have parentheses, because without it, your answer would be wrong. Okay. So now, what about 19? Now they're mixing it up because the bases aren't the same. So what should I do? Okay, I'm actually going to show you two ways. First of all, I'm just going to rewrite what I see. So I'm going to say 10 squared, that means 10 times 10. 5 squared means 5 times 5. And I'm going to notice something. Here, I notice 10 divided by 5. I can divide both of them by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And again, I could do it here. 10 divided by 5 is 2. 5 divided by 5 is 1. So altogether, I'm left with 2 times 2, which is 4. 1 times 1 is 1. So my answer would just be 4. Now there's another way. Here, I see that 5 can go into 10, right? So what I'm doing is I'm going to break it up. So I'm going to go ahead and put 5 squared in my denominator like so, but because I want to see if I can cancel out any 5s, I'm going to pull out 5s. I'm going to break it into 5 squared times 2 squared, okay? Because if you think about it, 10 times 10 is the same as 5 times 2 times 5 times 2. So essentially you have 2 5s and 2 2s. I'm just writing it like this. So that way I can see, oh look, I have 2 5s, 2 2s, and then 2 5s. Oh look, I can cross cancel. So that's just another way of thinking of it, okay? So again, the answer would just be 4 over 1, which simplifies to just 4. So this would be the answer, whoops, this would be your answer completely evaluated. Okay, so let's try number 20. Again, let's try it both ways. I'm going to extend 8 cubed out to just 8 times 8 times 8, because that's what it means. 4 squared to just 4 times 4. Here I see both 8 and 4 can be divided by 4. So I'm going to go and say 8 divided by 4 is 2, 4 divided by 4 is 1. I can do it again. 8 divided by 4 is 2, 4 divided by 4 is 1. Leaving me in my numerator with 2 times 2, which is 4, 4 times 8, which is 32, over 1, which is just 32. The other way to do it would be like, okay, I know that there's a 4 and 8, so I'm going to pull that out. I'm going to say it's 4 cubed times 2 cubed. Okay, and just write 4 squared underneath. So again, how am I making this possible? Well, 8 cubed is 8 times 8 times 8, but I can break it up to 4 times 2, 4 times 2, 4 times 2. And that's why I see, okay, I see there's 3 4s and 3 2s. So that's just another way. Because then I can say, okay, this is 4 times 4 times 4 times 2 times 2 times 2 over 4 times 4. Cross cancel, cross cancel. I'm left with 4 times 2 is 8. 8 times 4 is still 32. Okay, either or. Okay, so moving on. What about this one? Here's where it would actually be a little bit more helpful if you did break it up. So the first way I'm just going to show you is I'm going to write 10 in my numerator. I'm going to extend this out. 2 cubed is 2 times 2 times 2. 5 squared is just 5 times 5. Here, I'm going to go ahead and say, well, 10 divided by 2 is, well, let's say, sorry, rewind. I can divide both of these by 2. So 10 divided by 2 is 5. 2 divided by 2 is 1. But then I recognize, oh look, I can also cross cancel a 5. So I would cross out a 5 like so. Leaving me with 1 over 2 times 2, which is 4, times 5, which is 20. But that's not the only way. I could have said, well, here, a 2 and a 5 makes a 10. Excuse me. So 10 divided by 10 is 1. 10 divided by 10 is 1. Still leaving me with just 1 over 20. So I'm going to just teach you one last way of doing this. Since we have 2s and 5s, I understand that 10 can be broken up to just a 2 and a 5. And I can also cross cancel that way. Either way, I'm still left with 1 over 20th. So I want you to do it however you feel comfortable. Whatever naturally comes to you is going to be the best way. Okay, so now what about this one? Okay, let's extend it out. 8 cubed would be 8 times 8 times 8. 4 squared would be 4 times 4. 2 cubed would be 2 times 2 times 2. Okay, so I'm going to show you what I feel is easier for me. I'm going to go ahead and pull out an 8 by taking a 4 and a 2, because that's 8. So 8 divided by 8 is 1. This is essentially 8. That's going to become a 1. Same thing here. I'm going to pull out an 8 because I can pull out the 4 and the 2 because that makes an 8. Then last but not least, I can divide both of these by 2, leaving me with a 4 here and a 1 here. So my answer would be 4 over 1. Okay. Let me just show you one more example. If you want to, you can always see if they have common factors. Divide both of them by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Same thing. 8 divided by 4 is 2. 4 divided by 4 is 1. Keep going. Whoops. Let's go backwards here. Now I'm only left with 2, so 8 divided by 2 is 4. 2 divided by 2 is 1. And then here I can do cross out 2, so I'm going to 2 divided by 2 is 1. 2 divided by 2 is 1, which just leaves me with 4 over 1, which would just be 4. So there's multiple ways of doing this problem. Okay, do whichever you feel natural doing. These are just some suggestions. Okay, so now let's go ahead and try number 23. First and foremost, if you ever question of how to do things, always do extended products. That is your best bet. So here, I'm going to go ahead and extend this out. 3 repeated 2 times, negative 2 repeated 4 times. Here, 2 repeated 2 times, and 3 repeated 3 times. Oops. Here, you're going to cross cancel any numbers that you can. 3 divided by 3 is 1. 3 divided by 3 is 1. Now here, you have to be careful. I can cross cancel the 2's, but think about it. Negative 2 divided by 2 is a negative 1. 2 divided by 2 is 1. Same thing here. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. So you need to be very careful to not lose those negatives. So now, there's nothing left I can cross cancel. I want to take into consideration the negative sign. So we have a pair that's going to make it a positive. Another pair that's going to make it a positive. So my answer is going to be positive. Now I'm just left with a bunch of 1's and 2 2's. 2 times 2 is 4 over 1. So my answer would be 4. Okay. Oh, I'm so sorry. I got ahead of myself. Let's rewind here for a second. It's not 4 over 1. I missed it. I just realized there's actually a 3 here. So it's not 4 over 1. It's actually 4 over 3. So that's actually going to be a common mistake. You just saw me make it right now. So you want to be very careful that when you finish, you want to make sure you recognize every number that was not crossed out and simplified. Okay? So that would be my answer. So go ahead and pause the video and try number 24 on your own. Okay, so let's see how well you did. I'm going to go ahead and extend all of these out. Here I can see that the negative 4's cancel each other out, leaving me with 1's. And then here I'm recognizing a negative 4 and a 2 can be cross-canceled. Or you can think of it, hey, 2 times 2 is 4, that can cross-cancel, but I'm going to just take it step by step. Negative 4 divided by 2 would be a negative 2. 2 divided by 2 is 1. But then again, I can see 2 and a negative 2, I can cross-cancel again. Negative 2 divided by 2 is negative 1. And 2 divided by 2 is 1. Now this is where it gets a little bit messy, so you have to be very careful. I want to decide right now, is my answer negative or positive? Well, I have a pair here that makes it a positive, because negative times negative is positive, but then I have one last one. So my answer is going to be a negative. Now I want to make sure I catch every single number. There's a 3 times a 3, and the rest are 1's, so that's going to be a 9. What about the denominator? There's nothing but 1's, so that's just going to be 1. So I would confidently say that my answer is a negative 9. Okay. Awesome. So that actually concluded the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.